Do you ever wonder why we can walk and not fall through the ground like this crazy person? Or why this car can drive on gravel? And why this boat can move on water? This is all due to Newton's third law of motion. Now, before we get into the third law of motion, it is important we refresh our brains on the first two laws. Newton's first law of motion, which states that an object at rest remains at rest, and an object in motion stays in motion unless acted on by a net unbalanced force. Now we get to Newton's second law of motion, which states that an acceleration of an object depends on its mass and the amount of force applied. Rearranging the equation, we get A equals F over m. Now if we increase the force, we get a greater acceleration. Decreasing the force, we get a smaller acceleration. Decreasing the mass, we get a larger acceleration. And increasing the mass, we therefore get a smaller acceleration. Finally, what you guys have all been waiting for is Newton's third law of motion. Formally stated, for every action there's an equal but opposite reaction force. So how come when you sit in your chair, you don't just fall right through? Ah! This is because when you sit down, your body exerts a force on the chair known as Fg, the force of gravity. And the chair exerts an upward force of Fn. These together are called action-reaction forces. Observing an FBD, we can see Fg pointing downwards and Fn pointing up. Consider the propulsion of a fish through water. A fish uses its fins to push water backwards. The force is known as fish on water. And water reacts by exerting the force of water on the fish. So the fish is able to propel. The magnitude of the force on the water equals the size of the force on the fish, and the direction of the force on the water is equal but opposite to the direction of the force on the fish. These action-reaction force pairs make it possible for fish to swim. Now, the last example of Newton's third law of motion has to do with a beautiful-looking, large giraffe with incredibly pointy ears and antennas. In this situation, a trainer is standing on a stool and pulling on the giraffe. So there's a force of the trainer on the giraffe and the force of the giraffe on the trainer. But there's also the force of gravity and normal on both of these subjects. This can all be put together in a free body diagram, where there's force of gravity, force of normal, and the force of trainer on the giraffe, and also the force of gravity, force of normal, and the force of the giraffe on the trainer. To sum it all up, we see examples of Newton's third law of motion every day of our lives. Without it, cars wouldn't move, fish wouldn't swim, giraffe wouldn't be pulled on strings, and we'd all be falling down into the center of the earth. Overall, Newton's third law tells us that forces are like best friends. They always come in pairs.